Over the past decade, I think with digital technologies, we're seeing a second phase of technological changes. And this is much more of the kind of digital technologies and how we engage with electricity. And that's where the behavioral and experimental economics gets really interesting, I think. Back in the mid-90s, the Center for Neighborhood Technology did a project called the Energy Smart Pricing Plan. Right? And so some of the interesting things that we find and we focus on in behavioral and experimental economics has to do with pricing. Right? So we've had this regulated price now for 108 years, and it's this flat, averaged retail price, and it's the same for everyone in the residential customer class. But we all know that residential customers are very different. And some of us might be able to and be willing to respond to price signals, and others may just prefer to have a flat price and not have to think about it. And in any case, we know that a lot of the consumers that we care about also want that price to be affordable and as low and as stable and predictable as possible. And so under regulation, the only way to do that is by regulation. But now, one of the things that we are finding, and the Energy Smart Pricing Plan was kind of one of the things that started us doing a lot of research in dynamic pricing, is that if you do send price signals to consumers, can they respond? And if they respond, does that save them money? And do they use less energy? And so the Energy Smart Pricing Plan that CNT did in the 1990s was a great kickoff of this. And basically what they did was they took that wholesale market price, that PJM price, and 24 hours in advance, if there was going to be a high price above a particular threshold, so if you're participating in the project, you know, here's the price trigger, I think it was like 20 cents. If the price is going to go above 20 cents, which is a really high price, you're going to get a text message 24 hours in advance. But you're going to be committed, so you get 24-hour advance notice of the price you're going to pay. So at 4 o'clock tomorrow, if it's going to be really hot, we think it's going to be really hot tomorrow at 4 o'clock. That price that we're seeing in the wholesale market, that day ahead price, that's the price that we're going to charge you tomorrow at 4 o'clock. Right? So you get advance warning. And at this point, there's no sexy digital technology. But it's just advance warning and a text message. So that's the extent of the sexy technology, is you get a text message. And sure enough, and it was a demographically stratified set of participants. So you have rural, urban, suburban. You have folks living in multi-unit dwellings. You have folks living in single-family homes, and across the income distribution. And sure enough, all kinds of people would take actions to save money. And they would shift their energy use, they would change when they do laundry, just simple things that would save them money. And a lot of the concern that I thought was the most kind of meaningful outcome from this was the concerns about, is it going to be a burden, is it going to be hard for low-income customers to save money, because they mostly aren't going to have air conditioning, or they're not going to have a whole lot of ways necessarily to change their behavior. But what the Energy Smart Pricing Plan results showed was that because that that amount of savings is very salient, right? Even if you're just saving a little bit as a share of your income, that's, for low-income customers, that's a meaningful amount. And so if they can save any amount, that's going to be salient to them. And so even though it's just small changes, that they were willing to make the changes. And that they did save, in some cases, around 15% on their bills, which, when you're in an every little bit counts situation, that's, I think, very meaningful. So that's starting, and it started here in Chicago with CNT in the 1990s, looking at how sending consumers information about prices can induce them to change their behavior. And it's not a regulatory response, right? This is a market process that they're basically engaged in. So fast forward, and this is a piece of research done by Gesso and Raps in 2014, so it's a more recent piece of research, and what they did was they essentially replicated this same kind of setup, where you send price signals to consumers, and it's dynamic pricing, but what you have is you have two sets of customers. You have those who have a digital in-home display, and those who don't. Right? So they're paying that real-time wholesale market price that's being flowed through to them, and half the customers have a digital display and half don't. So half of them can see what their consumption is, and they can reflect back and look at what their consumption was, and the others don't. And what they found was that the customers who had the in-home digital display, that their average energy savings in quantity, in kilowatt hours, they reduced their consumption by 3 standard deviations compared to the control group that didn't have the technology, right? So if you think about a normal distribution, right, here's your mean. 2 standard deviations out is where your tail gets skinny. So if they're saving, if the difference between those two is 3 standard deviations, that's a big whopping difference. Right? So one insight we can get from that is the technology that communicates information to consumers can be really meaningful. And so if we can communicate information to consumers, they're more likely to act on it. And that'll save them energy and save them money. And so I know a lot of you are working on technology projects and ways to get technology that your populations can engage with meaningfully. And so the research suggests that that's a good thing to do. The other thing that was interesting about that paper is that what they also found was that these consumers who had this information, and so the energy and the economic savings were made very salient to them, that they also changed their behavior outside of the high price period. So even in the periods where you didn't have the red flashing light or you didn't have the high price number, they were reducing their energy consumption in those periods as well. Because it was basically oh hey, I've changed my settings on some of my devices in my home for this high price period, and now I'm realizing that I'm still comfortable, or my food is still frozen, or the behavior change has not changed their well-being. And so they just kept it throughout other periods of the day. And this is correlated with another piece of behavior that we see a lot that I'm going to call set it and forget it. And the one thing that we see a lot when we look at how consumers behave with respect to price changes is that they'll look at a price change and they'll think about it, and they'll maybe play, see what happens with it for a while, and then they'll change their settings on their devices in the home and then just forget about it. And I think that's why you see what they found in that paper was that the behavior changes persisted outside even of the high price periods. So that's pretty cool. One thing that I think that project takes advantage of, and that is on the frontier of some of the things that we're thinking about. I know ComEd is thinking about, because I was at an event they did yesterday. The Illinois Commerce Commission is thinking about with their Next Grid Utility of the Future project that is an 18-month project that's going to kick off starting tomorrow. And that is, how do we bring together these capabilities, these potentials that digital technology has given us, and how do we create more value for end-use consumers and do so with a very efficient distribution grid that has lower costs, lower emissions, and less resource use, but is still convenient and welfare enhancing for the end-use customers. And that's where I think the digital technology focus is really important. And so that in-home display, Gesso and Rapson paper, I think it has got me thinking about a lot of these kind of things. And so I want to just make a couple of comments about the role of digital technology and some of the research that we've seen in the decade or so that we've been experimenting with digital technology. And in particular, if you think about your daily lives, and I don't know how many of you are Amazon Prime customers, but do we love our Amazon Prime? Yes. Although the one thing I will not do is I do not do anything with one click. So think about how easy Amazon has made it for you to do the things that you want to do to go about your daily life in terms of kind of goods that you consume and that you want to have, say, in your home. I think for a lot of people, Amazon has made their lives way easier than it used to be. There are so many ways that digital technology has made it so that it's easier for us to accomplish the things we want to accomplish in our lives. And in economics, there's a field of economics that we can use to analyze those kind of things, and we call that reductions in transaction costs. Right? So I would argue that one of the main things that digital technologies have done in our daily lives is the reduction in transaction costs. It makes it easier for, and of course as an economist, I focus on exchange. And when two people get together and engage in mutually beneficial exchange, I give you this, you give me that, we're both happier, trade is made of win, right? That digital technologies have made it easier to achieve that trade is made of win outcome, and that a lot of that is what has driven a lot of the kind of internet-based growth that we've seen over the past decade or so. So if you take that that simple economic insight and go back to 2006, and this was a project that I worked on with the Pacific Northwest National Laboratory because it was in the Pacific Northwest. So have any of you ever been to the Olympic Peninsula in Washington State? Okay, what do you remember about the place? Lots of trees. Beautiful. Ocean, water, trees, mountain, beautiful. It is gorgeous. It is just a spectacularly beautiful part of the world. And so not surprisingly, they were having some population growth in the 90s, largely fueled by couples retiring to the northern part of the peninsula. The area, the electric network there they're served by Bonneville, which is the big federal hydroelectric power, the Bonneville Power Administration. And so they're the wires company, right? So they do the transmission and distribution wires. And so they have this big feeder, this transmission line going out to the Olympic Peninsula, and they're looking 5, 10, 20 years in advance, and they're looking at this population growth out to the Olympic Peninsula, and they're saying, we just don't have the capacity to serve those kind of customers if that population keeps growing, but it's the Olympic Peninsula, right? So what's the electricity industry's usual response to this is build more stuff. Right? Iron in the ground, build a generator there to serve that load, build more wires to carry more power to those people. Part of the reason that they're there is because it's beautiful, it's mountains, it's trees, and so they're there because of their environmental ethos. They want to appreciate the pristine nature of the location, but they also want to flip the switch and have the lights come on. Right, they don't want to be out on the Olympic Peninsula retiring to a yurt. This is, for me, a prime example of here's a situation where we can think about that alignment of economic and environmental incentives, right? And Bonneville's like, we don't really want to expand the feeder. We can't build generation there. And so they went to the Pacific Northwest National Laboratory, and the engineers there said, all right, so traditional supply response is not going to be the thing. Let's talk about demand response. And let's see if we can figure out a way to get better capacity utilization out of the existing system you have and have those people have the meaningful lives that they want with electricity consumption, with the environmental amenities, and save money at the same time, right? That would be the win-win-win. And so what we did was we did a project where we had 130 households, and we split them into 4 groups. There was, one was the control group, and all they had was the technology. Now this is where the technology starts to get sexy, right? And this is, I'm sure that like Nest and Ecobee and Honeywell are gonna be like, sexy food, but, right, because it's a two-way programmable thermostat, which for me is sexy technology, right? Because what makes this a great technology? Two-way programmable thermostat means that you, the homeowner, can receive a piece of information. You receive some data to your thermostat, and your thermostat can automatically, you can program in your responses. And we'll talk about what responses mean in a second. You program in your responses, and your thermostat automatically changes the setting on your, in their case, heater. For the kind of applications we might think about, it would be air conditioners, right? So the thermostat can change the settings on the HVAC automatically and send back information the other way saying, hey, I changed my settings. Here's the electricity I'm consuming. So that's what the technology can do, is it can send and receive data to and from the thermostat. So what kind of data might you want to send and receive? Not surprisingly, we're going to start with price. Right? And this was a price experiment, but you can think of other types of data that you might want to send and receive and have systems respond to. So we have this thermostat that is capable of receiving a price signal, changing the settings on the HVAC in the home, and sending back information to say, hey, here's the electricity I'm consuming. Right? So you have two-way flow of information and the ability to change settings automatically in the home. So we got 4 groups. We got one group that just has the technology, and it's got an in-home display, very much kind of like I talked about with the Gesso and Rapson, but probably less sophisticated because it was a little older. And then we had 3 groups that had different ways that they received price signals. One group had just flat price, right? So typical kind of plain vanilla, same price all times, every day, no matter what's going on with the weather, no matter that in different hours of the day, it's more or less expensive to generate the electricity you're consuming. And then we had a second group that had a peak and off-peak, right, a time of use price, and it had a critical peak. They knew that in some periods, if there was some scarcity of supply, that meant that they were really, really close to not having enough supply to meet all available demand, that you would have this huge critical peak price. And so they knew that coming in, but otherwise there was going to be a peak and off-peak price. And so you'd have the high price hours, 6 to 9 a.m. and 6 to 9 p.m. So when you're getting ready for work and when you come home from work and you're eating dinner. So those 6 hours were peak, the other 18 hours of the day were off-peak. And then the third group was the real-time price group. And what they saw was very much a real-time price. This was my part of the project. The way we constructed that market was the generators that we had, that would be our supply curve. But then we had the demand curve. And usually when we think about demand in electricity, we think consumers don't respond. Consumers don't want to respond. They just want to flip the switch and have the light go on, right? And so in economics, we call that inelastic demand. Right? That they're going to want to consume this much electricity. Well, the problem is that if that's what the demand curve looks like, and you have a supply restriction, that price can spike. And so real-time prices can be a bit volatile. And that's one reason why I think people get concerned at having, especially maybe low-income customers, see real-time prices. And I think that's a very justifiable concern. And so one of the things we wanted to figure out in this experiment was, do you have these price spikes when you have a real-time market like this, but you have a thermostat that can change the settings on the heater in the home, right? And so we had a group of consumers on this real-time price contract. And so what would happen, think of it this way. Your thermostat is bidding into that market. You know, I'm willing to pay this, I'm willing to pay this, I'm willing to pay this. And different people are going to set different prices that their thermostats are willing to pay. Some consumers are going to choose more comfort, and so they're willing to pay a higher price. Others choose more economy, and they're willing to pay a lower price. So what does that mean? Instead of your demand curve looking like this, your demand curve is going to start looking like this, because you now have these thermostats that are willing to respond to price signals because they are programmed by their owners to reflect the preferences of their owners, right? Now, so for me, this is a very empowering piece of technology, right? Because it means you have a choice. You choose the price at which you're willing to change the setting on your heater. You choose that trigger price for your home's uses of electricity. And we turned that into a market, just like this. And so we had our demand curve, we had our supply curve, we find a market clearing price, thermostats that were willing to pay that price or higher. It was, okay, stay where you are, don't change your settings. Thermostats that weren't willing to pay that price, the signal gets communicated back to them, hey, you weren't willing to pay this price, you need to change your settings. And so the thermostat would automatically respond based on what the homeowner told it to do. How awesome is this? This market occurred every 5 minutes for a year. And this is residential, retail customers. And they're out there living their lives, right? Because the strategy, we found out from surveys afterwards, the strategy they followed was set it and forget it. And that they might override their settings if they're having a party or the mother-in-law is coming over for dinner and they want to make sure it's nice and toasty so that she has a nice time, right? But they generally were set it and forget it. At the end of the project, the time of use, the peak off-peak folks conserve the most energy. And that varies. So there are other utilities that have done different projects like this. And sometimes the TOU group net conserves energy and sometimes it doesn't. It really depends on the prices you set. Not surprisingly, that real-time price group with the responsive thermostats, well, they all had responsive thermostats, but they're the ones that were responding to the real-time price. They saved the most. They saved 20% on their bill, on average, which is huge. Right? And we asked them after the fact, how did you like this? And they were like, this technology rocks. We love this. And then after the project was over, the local utility wasn't willing to keep supporting it. And so they came and took out the thermostats. And some of the participants were like, where are you going with my thermostat? I love my thermostat. So, so I think there's a lot of insights that we can get from this. One is that people can save energy and save money by using technology and automating their response to price signals. Right? And so they don't have to sit there and twiddle the dial. They don't have to be energy managers. They can go out and live their lives if they set it and forget it. And I think set it and forget it, especially when we think about consumers who are on fixed incomes, that one of the meaningful ways that we can help them save money is to harness technology in their behalf. And so for me, that's one of the reasons why I think this is such an empowering idea, is to automate responses to price signals, because that's a way that they can save money. And one of the surveys that we got in response said one of the most insightful things I have ever heard, that they actually really got it. Because this person said, I really like being on the real-time price, because by seeing that price signal, what that gave me was access to cheap overnight power. And if you're on that fixed price, you don't have access to cheap overnight power, right? And so that's the flip side of the, at 5 o'clock when it's hot out, it's going to be expensive. The flip side of that is, that means that at 2 a.m. it's going to be cheap as dirt. And so if you can use technology to shift your consumption in ways that doesn't inconvenience you, you can save money. And in experimental economics, so like the way we structured that project, we created a little account, a little budget that each homeowner got on top of their utility bill. And they got to keep whatever they didn't spend on their electricity. If you want to change incentives, that's the kind of change that I would have in mind. And so this project and what's come since has kicked off what we now call transactive energy. And so you can see why I focused on transactions. And the idea is to use algorithms and automation, use technology to automate responses to price signals so that we can lower our energy bills and lower our energy use. And I think one challenge for a lot of populations that, with issues like utility allowance or multi-unit dwellings where you don't necessarily have things sub-metered out. There are a lot of kind of those issues, but the kind of takeaway from me is, this is an under-researched area from an academic perspective. I'd like to see us do more kind of research, but I think there we need to partner with you all who are on the ground and ask, are there some ways that we can use these transactive technologies and these transactive ideas to help people save money and to change their incentives in ways that make them better off without inconveniencing them. The other main area that's strictly in behavioral economics with this has to do with the idea of peer effects. And in particular, there's a company, O-Power, that you may be familiar with, and ComEd and other utilities have worked with O-Power, and if you get a ComEd bill, right, you know this, right, that every once in a while you get a little letter that says, here's what your neighbors are consuming, here's what you're consuming. And the question is, how does that make you feel, right? Because this is what peer effects are about. The idea is, can we use peer effects to basically say, oh, wow, look, I'm an energy hog, maybe I should change my behavior, or wow, I am clean and green, the virtue feeling, right? And so there's some research. Alcott and Rogers, I think, is the in 2011 looked at this. They used O-Power data and personal comparisons, and what they found is that when you initially start getting those, will lead to big initial reductions, but then those diminish over time. But that even after 2 years, there is still a persistent effect, that there is still a persistent reduction in energy use. Right? So I think that those kind of neighbor comparisons and peer effects has had some effect in reducing energy use. So I think the big punchline for me is that we can think about the fact that digital technology is pervasive in our lives, has reduced transactions costs in many dimensions, and that we can harness that capability in electricity use to reduce bills and reduce consumption without reducing the well-being of consumers. That's a big empowering opportunity to help people feel like they are in control of their energy use and that they can benefit from using technology to help them reduce their energy use and save money at the same time.